One of the biggest challenges when you build a control room is to keep the functionality of the existing control rooms going. And so we had already done firing room 1 mostly. And so when we did that, we did not do the historic way of doing things. We had run cabling in the past through the different control rooms to support. So all the cabling comes into each firing room now. Because when you run them through the firing room, you risk cutting cable that you shouldn't have cut. So on most launches, there's a no dig or no cut. And so it was important to, when we went through, not to cut stuff that we had. And we did a little bit of that. Some of the guys had these big battery-powered DeWalt things, and they would come up and there would be a cable with a 200 pair cable in there, and they're like, if I cut that, it's going to take me all day to fix it if it's wrong. And so you'd cut it and kind of wait to see what happened. So it was a challenge from that perspective to understand, how we're going to clean it out and how we're going to get it done. And we have proceeded throughout the rest of the building to pull cable to get the rest of the building in line with the new program. We aren't launching rockets right now, so now is the time to do that kind of maintenance. We've gone through and replaced the windows have been replaced over the past few years. The front windows, all the shutters have been taken down that covered the front windows for, there's 2 theories on that. One was that they were blast windows, that you had these big shutters that would close on the front to protect the window. Mainly the other prevailing thought was that they were for glare, to keep the glare down, because it's quite a big window. So we went through and cleaned up all those. We replaced all the windows and doors. We painted the building. And we're continuing to do that and look at all the mechanical systems to make sure we're ready for the next GSDO program to launch SLS and Orion. To understand risk is a really, really touchy thing. What is risk? And when we talk about risk, what do we mean? What are we trying to manage? So there's a couple of ways to look at it. There's the risk of not being able to complete the mission, okay? There's the risk of running over budget. There's a risk of breaking one of these sides of the teeter-totter so that you don't achieve the mission. So when you look at that, budget is a reality. We don't have an infinite budget, and we don't have an infinite schedule. And there's things that we can't build that operations wants us to build. So when you look at all of those, each one of those areas comes with inherent risk. Writing software, as we have talked about a little bit, knowing how the other programs' software requirements are changed, to integrate those changes in the vehicle and in the spacecraft and the ground systems and work those into the command and control system that can't just deliver a build every week to change requirements. You have to plan ahead. So probably the biggest risk in the command and control area is the software related to making sure we understand how the software needs to function and the requirements of the software as needed by the Orion program, SLS, and all the people that are putting in, and making sure we get that done. The best way to manage that is to work closely with a team, to have some people that communicate well. You can't spend all your time in meetings. And so you have to make a decision and go forward. I learned in college from one of my professors that there's lots of ways to get to Burger King. Sometimes it's best to just go. But you have to go with some knowledge of what you're trying to accomplish. And so when we write software, we write down the requirements, and we have to do this spiral cycle that I've been talking about so that we can work them in. If we don't get the functionality we need, then we start running into other risk. Risk of personnel safety, risk to the vehicle, risk to the mission. So those are areas we don't want to get into. So, to run late on a schedule is a risk, but to put any personnel at risk as well is not acceptable. So when we talk about risk as far as personnel, it's important to say, GSDO and SLS and Orion, their primary focus is to make sure we keep personnel safe and the vehicle safe. We do that by being efficient as engineers and doing the best job that we can. But ultimately, as we build things, we're not done until we come up with a design that's safe for personnel to operate and and to protect the vehicle. When we've done that, we're finished. If we haven't done that, we're not complete yet. So that's how we kind of manage risk in the best way possible. I've worked for NASA for 28 years. My primary focus has been on communication and building control rooms. So in that light, I've worked on about 35 different control rooms, some as quite a few as project manager. So one of the tricks there to be successful is to work closely with your team. But it is important to give your team the authority and the capability and the freedom to be creative, to come up with solutions that are not what you would have thought of. As a project manager, I don't need to dictate how they do their designs. I need to listen to the engineers. The smartest people in the program should be the design engineers. The project managers need to give them the resources. So one of the tricks that I have done is you get good smart people working for you, hopefully smarter than you are, so they can solve problems that you don't know how to solve, to give them the room that they need to build it. Give them a budget, give them a schedule, hold them to that budget, hold them to that schedule, but demand that they be creative. Don't just bring back to me the same tricks that you've used for 28 years. Come up with something new. And that's really important because NASA likes to bring in new engineers, and what they lack is the experience. And so one of the pertinent tricks is to mix the new engineers with the motivation, engineering the new ideas, with the older engineers that have the experience, and to blend that team together, old and new, to accomplish a task that neither one of you could do together. As you get older, you want to take less risk. As you're younger, you don't really understand what the risk is. But I've had my foot stepped on a few times, and had a few situations that we had to iron out. And the new team, the new engineers are willing to take those leaps, and we temper them with the bruises that we've suffered over the years. No one wants to make a mistake. No one wants to look bad. So you have to balance that. Other things are, like we had mentioned earlier, we talked schedule. Whenever you have time, make schedule. If you've already gone past it, you can't get it back. So if you see a way that you can reduce schedule, continually look at finding the critical path, understanding what's causing you your schedule creep, and work on that as a team. Get other people in other areas to see if there's ways that they can come in and look at it. Independent evaluations. Have people review drawings and designs that aren't part of that standard design package, so that they can look and say, well, you've missed the obvious that's out in front of you because they're not looking at it in the same way. When I was in math, if you did the same problem wrong, you had a tendency to do the same problem wrong again, and again. So you had to stop, put it down, and come back and look at it again. And so that's another way of doing it. If you're jammed up against the log, stop, take a break, go home, think about it, come back the next day, and you have a tendency to pick up new ways of looking at things. So that's been an important tool as well. The last one is probably try and make sure your team's having fun if they're enjoying their work. If somebody's not enjoying what they're doing, they will not do a good job. If they like what they're doing, you can't make them go home. When I first came out here, we worked in Space Lab. There wasn't a guy in the room that was over 26 or female. You couldn't make us go home. We'd work till 11, 12 o'clock at night, come in the next day, do it again. We had fun. We had a lot of fun. And if your team's having fun, that's paramount in a project. If your team's having fun, you're going to get good work. You're going to get people that are dedicated and enjoy what they're doing, and they'll have fun, and they'll do great things for you. And you trust them.